Hi everyone. We'll start in 10-12 minutes. I'll wait for people to join and then we shall start. Okay. Okay, we'll start now. Sorry, my mic was off. I'll share my screen. Yeah. Yeah, so in week 5, the topics covered were mostly differentiability, the definition, then again, I think the algebra of differentiable functions, all this was covered, and how to find whether a function is differentiable at a point, and some cases when it is not differentiable, that also are discussed. And then about the slope of tangent, uh, or the slope of the curve at a point. And then there were some results like differentiability implies continuity at a point. Then about the horizontal and vertical tangents, and then about the chain rule, the derivative of the f inverse, implicit derivative, equation of tangent and normal, and then also briefly he discussed about the higher order derivatives, right? So we'll do the questions based on that. And again, as I always tell in my video, that my motive here is to help you do the assignments so that you can pass this course with good grades. So yeah, so most of the questions I do are very uh, close to the questions that you get in the assignments in your NPTEL course. So yes, so today also we'll do that. So question number 1, it is based on derivative of a function. Question number 1, if x y square is secant 2 root x for x not equal to 0, then 2x square y cos 2 root x dy by dx is equal to, you're given an expression relating y and x, and you are supposed to find a relation between dy by dx and y and x. I'm sorry. So, your options are root x tan 2 root x plus 1, b root x tan 2 root x minus 1, c, and b minus root x tan 2 root x plus 1, and of course minus x tan 2 root x minus 1. So your obvious step to start the question is to differentiate the given equality you have been given, or the given equation. So you are given xy square equals secant 2 root x. So I hope you remember the chain rule and everything from the course or from the this week's video. So differentiate the above equation with respect to x. What do we get? We will here apply the product rule. So firstly differentiating x is 1, y square as it is, then differentiate x as it is, then differentiating y square, it will be 2 y dy by dx Here when we were differentiating with x, it was majorly dx by dx, so which was 1. Okay, now we'll apply the chain rule, right? So secant x derivative is secant x tan x, so secant 2 root x tan 2 root x. Now the derivative of the function 2 root x, it will be 2 into 1 by 2 root x. Give me a minute. Yes, sorry. Yeah, so what we differentiated secant x, which is secant x tan x. X is here is 2 root x, but if we wrote secant 2 root x tan 2 root x and the derivative of the function 2 root x with respect to x, this is the chain rule. This is what the chain rule says. So it will be 2 into 1 by the derivative of root x is 1 by root x. Sorry, 1 by 2 root x. So it will be 2 into 1 by 2 root x. The derivative is of root x. How do we do? It is equal to 1 by 2. So 1 by 2 x and 1 less power. So it will be 1 by 2 x to power 1 by 2. So that's it. That So we will do some questions later today in the session where we'll find the derivative using the definition. So it will be more clearer. It will be more clear. So anyway, so you know this power rule sir had discussed in the class. So you can use that here directly. Okay. Now your task is just to solve this. So what do you have to find? You have to find 2x square y cos root x. So you'll just try to make this form here. So it is x square plus 2xy dy by dx equals to secant 2 root x tan 2 root x into 1 by root x. So you'll just, since you need here, what do you need? X square y, you have x, y here. So you'll just multiply by x, y square x plus 2x square y dy by dx equals to x upon root x. I just taken this here, secant 2 root x and tan 2 root x, right? And next, what do you need? Is you need a cos 2 root x with it. So it is cos 2 root x multiplying y square x plus 2x square y dy by dx cos 2 root x equals, this will become root x cos 2 root x into secant 2 root x will cancel out, so it will be tan 2 root x, right? So what do you get? Okay, also you know that xy square is secant 2 root x, so this will become given xy square is equal to secant 2 root x. So cos 2 root x into xy square is 1. So implies 1 equals 2x square y dy by dx cos 2 root x. So 1 plus equals root x tan 2 root x. So this implies 2x square y dy by dx cos 2 root x is root x tan 2 root x minus 1. Okay. So you see, you were given that x not equals to 0. That's why this is making this line or this equation is making sense here. So everything that is given in the question or the hypothesis makes sense. I mean, there's the reason that has been given. Okay. So your correct option becomes root x tan root x minus 1, which is C. Okay. Hmm. Next question. Suppose f of 1 is 1, g of 1 is 2, f dash 1 is 3, g dash 1 is 4, and hx is fx minus gx upon 1 minus gx. Then you have to find the value of the derivative of the function h at the point 1. And your options are A option minus 1 by 3, B option 1 by 3. I hope I was not at mute. C option is minus 3 and D is of course 3. So hx is the quotient of two functions. So you will apply what quotient rule? So h dash x is applying the quotient rule. One minus gx square. Then the derivative of the, so the denominator here into derivative of the numerator minus the numerator and the derivative of the denominator. So by algebra of differentiable functions, you have this 1 minus gx, f dash x minus g dash x minus fx minus gx, and 0 minus derivative of a constant function is 0. Derivative of gx is I have written minus gx upon 1 minus gx. Now you simply have to put all the values. You have to find the derivative at the point 1. So this will be 1 minus g of 1 into f dash 1 minus g dash 1 minus f of 1 minus g of 1, and minus, I'll just put plus here, g dash 1 upon 1 minus g1 square. So this is g1 is 2. So 1 minus 2, f dash 1 is given to be 3, g dash 1 is given to be 4, plus f1 is 1, g1 is 2, g dash 1 is 4. 4 upon 1 minus g1 is 2 square. Okay, so this is minus 1, 1 plus minus 1 minus 4, right, upon 1 minus 2 is 1 and square minus 1 square 1. So this is minus 3. So correct option is C. So C is the correct option. So you were given the derivative of functions at some point, and and a new function is formed using those functions, and you were supposed to find the derivative uh, at the same point of the new function. And there we use the quotient rule, product rule, not exactly how we use the product rule, but yeah, question rule and the algebra of limits, differentiability. All right. Question number 3. If x raised to power 2 by 3 plus y 2 by 3 is 2 for x not equals to 0 and also y not equals to 0, then you have to find the modulus of the double derivative of y at the point 1. Again, you have given a relation between x and y and you are supposed to find the double derivative of y at the point 1 and the modulus of that. So again, your obvious step is to differentiate the given equation, right? So you are given x 2 by 3 plus y 2 by 3 equals 2. So you will use the uh, what is it? Power rule. So power पहले power एक कम plus I usually used to remember this rule by this power पहले power एक कम and the derivative of uh, y with respect to x and 0, right? We're considering y to be a function of x. You can also do the other way round, but since you have to find y double dash, so I'm considering y to be a function of x. You can also find dx by dy, that's not a problem. But since we have to find d square y by dx square, that's why I'm doing this. Okay, so this is 2 by 3 x minus 1 by 3 plus 2 by 3 y minus 1 by 3 dy by dx equals 0. So you have 2 by 3 x minus 1 by 3 equals minus 2 by 3 minus 2 by 3 dy by dx. So this can get cancelled. So you have x minus 1 by 3 minus y 1 by 3 equals dy by dx. Now differentiating again with respect to x because we have to move to the second derivative. So now we'll use the right hand side will be d square y by dx square simply, and here we'll have to use the product rule, keeping the mind side as it is outside. So product rule is first function derivative of the first function minus power पहले power एक कम y 1 by 3 second function as it is plus first function as it is and the derivative of the second function power पहले power एक कम, right? So this is minus, I'm keeping still as it is, 1 by 3 x minus 4 by 3 y 1 by 3 plus 1 by 3 x minus 1 by 3 and y 1 minus 3 minus 2 by 3, correct? So what do you get? 1 by 3 multiplying with the negative minus 4 by 3 y 1 by 3 minus 1 by 3 x minus 1 by 3 y minus 2 by 3. Have I done something wrong here? Yes, I have not written. When I was derivating this, there will also one term of when differentiating with y dy by dx. I'm sorry I missed that. Now in the next step, I'm just putting the value of dy by dx from here. This will be minus 1 by 3 x minus 1 by 3 y 1 by 3. So this will be positive. Now adding the power is x minus 2 by 3 and y is minus 1 by 3. I'm sorry, from a mistake. Yeah. So finally you'll get 1 by 3 x minus 4 by 3 y 1 by 3 plus 1 by 3 x minus 2 by 3 and y minus 1 by 3. Now you have to find the double derivative of y with respect to x at the point 1. So at the point 1. Now see, when you have also been given a relation between x and y, now at point 1, what is the relation? X 2 by 3 plus y 2 by 3. This should be satisfied at all times. So when you put x equals to 1, x plus y 2 by 3 equals to 2, y 2 by 3 equals 1, y equals 1. So at x equals to 1, y is also equals to 1. So by this we get d square y by dx square at the point x equals to 1 is 1 by 3. You'll just have to put the power, or you should here say, here you will get, if you do the power 3, y square equals to 1 implies y equals plus minus 1. Right? So when x is 1, y is plus minus 1. So when x is 1, if you put y to be what? Minus 1, y to be 1, so it will be 1 by 3 into 1, 1 plus 1 by 3 into 1 into 1, which is 2 by 3. Right? So when you put d square by dx square at x equals to 1, this was when y equals to 1, when y equals minus 1. So this will be 1 by 3, x is still 1, y is minus 1, and plus 1 by 3, 1, and y is minus 1. So this will minus 2 by 3 implies the modulus of y dash double dash 1 at the point 1 is 2 by 3. Right? So minus 1 raised to power minus 1 by 3 is minus 1, then minus 1 raised to power minus 1 by 3 is minus 1, so we'll get minus 2 by 3, and the modulus will be 2 by 3. Right? So our correct option is, no, I did not give option there. So A is 1, B is 2 by 3, C is 1 by 3, and D is 0. So correct option is C. Okay, I hope it's clear. Okay, so the next question is on tangent of the curve. So the derivative of a function at a point also gives the slope of the tangent at that point to the curve. So the tangent is the line which touches the point at a point is the line which touches the curve at only that given point. We say that line is the tangent to the curve at that point. So the question is, the points on the curve y equals 1 plus 2x plus 2 by x, where the slope of the tangent to the curve of the tangent to the curve is minus 6r. So you've been given a curve, you have to find the points where the slope of the tangent to the curve is minus 6. So 1 by 2 comma 6, and these are your options. B 3 by 2 comma 16 by 3, and minus 1 by 2 comma minus 4. C 1 by 2 comma 6 and minus 3 by 2 comma minus 10 by 3, and D 3 by 2 comma 16 by 3 and minus 3 by 2 comma. Okay, so I'll wait for 2-3 minutes for you to try. Please try this question. So I hope you are able to solve this. So you have to find firstly dy by dx, and you have to see the points where dy by dx is equal to minus x. This is the question. So you have given the curve y equals 1 by 2x by 2 by x. So differentiating will get dy by dx equals 0 plus 2 and derivative of 2 raised to power x inverse power पहले minus 1 and power ekam x minus 2, so 2 by x square. So let the required point, meaning the point where the derivative is minus 6, is be a comma 1 plus, so y will be 1 plus 2a plus 2 by a. So y dash a equals minus 6 implies 2 minus, we'll put the value at 2 minus 2 by a square to be minus 6. Okay, so this implies minus 2 by a square is minus 4. Implies, so minus 8, right? So minus 2 by minus 8 is 4 equals a square, implies a equals plus minus 1 by 2. So when x is 1 by plus minus 1 by 2, y dash a will be minus 6. So you have to find now the corresponding uh, y coordinate. So when a is 1 by 2, y of a is what is the value? 1 plus 2x plus 2 by x. So at the point 1 by 2, it is 1 plus 1 plus 4. So it is 4 plus 1, 6. So one point is 1 by 2 comma 6. Now when a is minus 1 by 2, y of minus 1 by 2 is 1 plus 2 into minus 1 by 2 plus 2 1 by 2. So this is 1 minus 1 minus 4, right? So minus 4. So second point is minus 1 by 2 comma minus 4. So the correct option is 1 by 2 comma 6 and a, right? So this is okay. Question number 5. Now again question on slope. The slope of the curve sorry, the slope of the curve x cube plus y cube plus x square y square equals x minus y minus 1. So here you see there are no explicit expressions of y in terms of x or x in terms of y. These are all implicit equations, right? At the point 1 comma minus 1 is you have to find dy by dx at the point 1 comma minus 1. So A option is negative, B option is positive, C option is 0, and D option is not defined. So you just simply, again, what do we do? Derivate the equation or differentiate the equation. So x cube plus y cube plus x square y square equals x minus y minus 1. Differentiate with respect to x. So you'll get 3x square plus 3y square dy by dx. Here you'll use the product rule. Derivative of x 2x y square plus x square 2y dy by dx equals 1 minus dy by dx minus 0, right? So what do we have? So dy by dx on one side we have to find 3y square. I'm taking common dy by dx. 3y square plus x square from here 1 equals 1 minus 2xy square minus 3x square. Right? So you get dy by dx equals 1 minus 2xy square minus 3x square upon 3y square plus x square plus 1. So at the point x equals to 1, at the point 1 minus 1, this is 1 minus 2 into 1 minus 1 square minus 3 into 1 upon 3 minus 1 square plus 1 square plus 1. So this is 1 minus 2 minus 3 upon 3 plus 1 plus 1. So this is 1 minus 5 minus 4 upon 3 plus 1, 4 plus 1. I've done some calculation mistake, it seems. Yeah, here it is 2y also. 2y 2y x square. So it is 2 into minus 1 also. So it is minus 2. Yeah, which is less than. Also, note that the point where we are finding the tangent has to lie on the curve. So it is very necessary to check whether the point we are finding the slope of the curve at that point is lying on that curve. So you see also 1 minus 1 satisfies the given equation. You check that. Do it yourself. Yeah, so you can check that the point implies 1 minus 1 lies on the curve. So we were able to we can find the slope of the tangent to the curve at that point. All right. Next question. If the line passing through the points 1 comma 2 and minus 1 comma 4 touches the curve y equals to 8 upon a plus 2x in the first quadrant, then a is so you are given that there is a line with passing through 2 points, one when this, and it touches the curve. Suppose this is the line 1 comma 2 and minus 1 comma 4 somewhere here. Okay, and it touches the curve in the first quadrant. It touches the curve. I should yeah, something like this. This is the curve y. It touches the curve in the first quadrant. So this is the point some 1 comma 2 and this is minus 1 comma 4 and it touches the curve and this is the curve 8 by a plus 2x in the first quadrant at some point a comma ya is yx equals this is the curve because the point lies on the curve. Then you have to find the value of this a. Now see, so what do we suppose, let the point be given by not do not suppose to be 8 because a we have already given the curve, b comma y comma b, this point where it touches the curve. Let the point in the first quadrant in the first quadrant be given by, and we satisfy all the conditions we have been given the question, given by b comma yb, that is b comma 8 upon a plus 2b. So since it lies in the first quadrant implies b is greater than equal to 0 and 8 upon a plus 2b is greater than equal to 0 and this is greater than equal to 0 whenever it is always positive because it cannot be equal to 0, because if it is equal to 0 then we'll get 8 equals to 0 which we cannot have, so we'll have if and only if a plus 2b is positive, right? So we have these two conditions. Now we want that the slope of the tangent to this curve at the point b comma yb it will be equal to the slope of this line. So we'll have two conditions. Firstly, the slope of the tangent through the curve and the slope of the tangent through the 2 points it is passing through. So slope of the tangent at the point is to the curve is y dash b equals, we just have to derivate the given function and put the value x equals to b. So it will be 8 into a plus 2x का derivative minus 1 power पहले a plus 2b square into 2x का derivative into 2. So minus 16 upon a plus 2b square, right? And the slope of the line is also by passing through what is 1 comma 2 and minus 1 comma 4 is 4 minus 2 upon minus 1 comma minus 1. So it is 2 upon minus 2 equals minus 1. Implies this has to be same. Both these slopes has to be same, equals minus 1, right? So implies a plus 2b square equals 16, right? Implies a plus 2b equals plus minus 4. But we know, because we have reduced here, that a plus 2b is positive, a plus 2b greater than 0 implies a plus 2b is 4. Now our task is to find the value a. So we have one more condition, which is that this point also lies on the curve. So now the point becomes 2 comma 8 upon a plus 2b equals 2 comma 8 upon, just put it here, 4 equals 2 comma 4. This was not 2, this was b, right? 4b comma 2. Also, this point lies on the curve, lies on the curve, and that is what we have found, on the curve and the line. So firstly, the line joining the 2 points is points minus 1 comma 4 and 1 comma 2 is y minus 2 equals, the slope was minus 1 and x minus 1. So this is y minus 2 equals minus x plus 1. So this is y plus x equals 3. So b comma 2 satisfies the above equation, implies 2 plus b equals 3, implies b equals 1. So we have found b, but our task was to find a. But we have one more equation in terms of a and b, which is a plus 2b has to be 4. Also, a plus 2b equals to 4. So just put the value of b, a plus 2 equals to 4 implies a equals 2. So, this question has judged all your knowledge about the equation of the line, the derivatives, and the slope of the tangent at a point to the curve. So, this is a very good question. You just try to think it yourself. If you're not able to, if you have any doubt in any step, just let me know in the comments. I'll help you out. So, our correct answer is B, that the value of A is 2. Okay, so what we did, we were given that the line passing through the points 2 touches the curve in the first quadrant, then we have to find the value of A, which was in the definition of the curve. So we'll let the point to be b comma yb, since it is on the curve, so it will satisfy the equation of the curve. So the point is b comma 8 upon a plus 2b. Now using the derivative, we found the derivative at the point b comma 8 plus 8 upon a plus 2b, and also the slope of the line through joining the 2 points, which we know is 4 minus 2. This is a formula in geometry you all know is -1, and they both have to be equal. From there we found the relation between a and b, which was a plus 2b equals to 4. Now our task is to find one more equation in a and b, because we need to find a. So also we know that this point lie on the line joining the given 2 points. So we found the line joining the given 2 points again using the 2 point form you study in your geometry classes in 11 12 standard, that 5 minus 2 equals to slope x minus 1. You could have also used the point -1 comma 4 here. That's not an issue. We got the line to be y plus equals 3, and now the point b comma 2 lies on this point on this line. So we found the value of b, and we already had a relation between a and b, so we put the value of b there to find the value of a which we needed, and that's how we solved this question. Okay, I hope it was clear for everyone. So question number 7, the equation of tangent to the curve. The curve you have been given in parametric form, x equals to 1 plus 2 by t, y equals to 1 minus 2 by t square at the point two comma 1 by 2 is, you have to find the equation of the tangent to the curve. The curve has been given in the parametric form. So the parametric form is you are given the variables in the curve in some other coordinate which varies, like t varies here to give you the value of x and y. That's what parametric form in a layman language basically means. So a is x plus 2y equals 3, b is 2x plus y equals 9 by 2, c is x plus y equals 5 by 2, and d is x minus y equals 3 by 2. So you have to find the equation of the tangent. So to find an equation of a line, you generally need either 2 points on the line or a point and a slope. So you already know a point on the line 2 comma minus 1 by 2, that equation of tangent, that meaning that the tangent to the curve at this point has to pass through the point 2 comma 1 by 2. So you have one thing. Now the another is you can find the slope since you are given the curve. So our task is to find the slope at this point 2 comma 1 by 2, and slope of what? Slope of the tangent to the curve found by this equation at the point 2 comma 1 by 2. All right, so what do we do? So xt is 1 plus 2 by t. So dy by dx in terms of parametric form can be written as dy by dt and upon dx by dt. This has also been covered in class, so you can go and see the video there. So dx by dt is 0 minus 2 by t square. Yt is given to be 1 minus 2 by t square. So dy by dt is 1 minus 2 into minus 2 upon t cube. Sorry, 0. So this is 4 upon t cube. So dy by dx is dy by dt upon dx by dt. This is 4 by t cube 1 minus 2 by t square. So this becomes minus 2 by t. So now you have to find the point, find the tangent to the point, to the curve at this point, x and y. So you have been given the point in terms of x and y. Now you need to find the corresponding t, that to which t that this point corresponds. Because how how is the curve defined? The curve is defined as t varies. T varies from here. There is no given. There is nothing given about the domain of the t. So we assume that t varies from minus infinity to infinity, excluding 0 because t is in the denominator, and it will give the value of x and y, and you plot the value on the 2D plane. Now it's the reverse, that you have been given a point in terms of x and y, and you have to find to which t does this point correspond. So how do we find that? You simply put it in one of the equation, like x plus, so sorry, x is given to be 1 plus 2 by t, and y is given to be 1 minus 2 by t square. So if 2 upon 1 by 2 lies on this curve, it will correspond to some t. So if x equals to 2, so if you put here 2 equals 1 plus 2 by t implies 1 equals to 2 by t implies t equals to 2. Also, if you put t here, y equals 1 minus 2 by 4 equals 1 minus 1 by 2, so 1 by 2. So we have got, for this t, we can find for t equals to 2, the point that will correspond on the curve is 2 comma 1 by 2, and vice versa. If 2 comma 1 by 2 lies in the curve, so the t that it corresponds to is t equals to 2. So t equals to 2, so implies dy by dx at the point 1 2 comma 1 by 2 corresponding to t equals to 2, and it is equal to minus 2 by t, so it is minus 2 by 2 equals minus 1. Okay, so the equation of tangent is, we know the point, we know the slope, so just simply y minus 1 by 2 equals minus 1 and x minus 2. So solving it, we get y minus 1 by 2 equals minus x plus 2. So y plus x equals 2 plus 1 by 2 equals 5 by 2. Right? So the equation of the tangent at the point of 2 comma 1 by 2 is y plus x equals 5 by. So it is C option. Right? I hope all these questions were clear to you guys. Okay. So next is how to find the derivative using the definition. Derivative at a point of a derivative of function at a point using definition. So I'll do some questions on that because these are the basic you should be thoroughly clear with, right? So steps for calculating f dash x from the definition is, firstly you write the expressions of fx and f of x plus h. Okay, then you expand and simplify the difference f of x plus h minus f of x upon h. Then third, using the simplified question above, find f dash x by evaluating the limit h tending to 0 f of x plus h minus f of x upon h. Okay, so you find fx and f of x plus h, then you find the ratio fx plus h minus fx upon h, and then you find the limit h tending to 0 to find f dash x. Basically, you are finding the how x value of f is changing when you just change x a little bit. Okay, this is what basically the derivative is. So the question is, using definition, find f dash 3 where fx is 4 minus x square. I'll wait. Just try this. So it is not difficult. So we'll follow the steps. We'll find f(x) is 4 minus x square, f of x plus h is 4 minus x plus h square. Then f of x plus h minus f of x upon h is 4 minus x plus h square minus 4 minus x square upon h. So this is 4 minus x plus h square minus 4 plus x square upon h. This gets cancelled. So this is minus x square minus x square h square minus 2xh minus x square upon h. So this is h also will get cancelled, minus h minus 2x. Third, limit h tending to 0 minus h minus 2x is minus 2x. So at the point, what was it? F dash 3. So f dash 3 is minus 2 into 3 equals minus 6. Okay. Similarly, you can find f dash at any point. So B part is P theta is root 3 theta. You have to find P dash 1. Again, we'll find P of theta plus h equals under root 3 theta plus h. Then P of theta plus h minus P of theta upon h. It is under root 3 theta plus h minus under root 3 theta upon h. Will rationalize it. 3 theta plus root 3 theta upon under root 3 theta plus h, multiply and dividing, and under root 3 theta plus h minus and 1 h. So this is 3 into theta plus h minus a square minus b square, 3 theta plus h plus into h. So this is h, 3 theta cancels, h upon h under root 3 theta plus h plus under root 3 theta. So limit h tending to 0, 1 upon 3 theta plus h plus under root 3 theta is 1 upon, here it will be 3h. So it is 3 upon, we will get 3 theta plus under root 3 theta. So we will get 3 upon 2 under root 3 theta, right? So P dash 1 is 3 upon 2 under root 3 equals under root 3y, right? So question number, this is how you can find the derivative of function at a point using the definition. Okay, so question number 9th, find the slope of tangent to the curve w equals g of z equals 1 plus 4 minus z at the point z comma w equals 3 comma 2. So you have to find g of g dash z to find the slope. So g dash z by definition will go limit h tending to 0, 1 plus 4 minus z minus h minus 1 minus 4 minus z upon h. So we will Rationalize it. 4 minus z minus h minus will get cancelled. 4 minus z plus 4 minus z minus h plus 4 minus z into 4 minus z minus h minus 4 minus z and 1 h. This is a square minus b square. 4 minus z minus 4 plus z upon 4 minus z minus h plus 4 minus z into h. So this cancels, and this cancels. So minus 1 upon limit h tending to 0, limit h tending to 0, 4 minus z minus h plus 4 minus z. So this is minus 1 upon 4 minus z plus 4 minus z equals to minus 1 upon 2 into 4 minus z. So g dash of 3, you have to find the limit at the point 3 comma 2 is minus 1 upon 2 into 4 minus 3 is minus 1 by 2. So this is the slope of the tangent to the curve gz at the point 3 comma 2. Okay, all right. So next question, right? Discuss the differentiability of the given function fx equals x at the point, you have to check at the point x equals 0, 0 and x equals to 0. So this type of question, if you remember, we have done while doing the limit. So you have to check the different if the derivative or if the function is differentiable at the point x. So till now, what questions we have done, it included somewhat like the uh, polynomial type of limits where the limit at every point existed, right? So here we'll have to check. So we'll have to check f of right hand derivative and left hand derivative. So right hand derivative is limit h tending to 0 plus f of 0 plus h minus f of 0 upon h. So here we are checking the derivative at the point 0. So this is limit h tending to 0 plus f of h is h e1 by h minus e1 minus h upon e1 by h plus e minus 1 by h minus 0, f0 is 0 upon h. So this is cancelled. So this is limit h tending to 0 plus, what we can do, we can take e raised to power 1 by h to the other side to get 2 minus h and 1 plus e raised to power minus 2 minus h. So this will be h tending to 0, 2 by h tending to infinity. So e minus 2 by h goes to 0. So this will be 1 minus 0 upon 1 plus 0, it is 1. This was the right hand derivative. Now left hand derivative is limit h tending to 0 plus and f is a minus h, where h is tending to 0 plus a minus h is minus f of 0 upon h. So this is limit h tending to 0 plus h e raised to power, f of minus h will be e raised to power minus 1 by h minus e raised to power 1 by h upon e raised to power minus 1 by h minus e raised to power minus 1 by h, sorry, plus 1 by h, right? Minus 0 is 0 upon h. So this gets cancelled. Now I will take e raised to power 1 by h to this So this term minus 2 by h minus 1 upon e raised to power minus 2 by h plus 1. So again, as using this like this, we'll get limit to be 0 minus 1 upon 0 plus 1. So minus. So the right hand derivative was 1, right? 1. And the left hand derivative is minus 1. So left hand derivative not equals to right hand derivative implies f is not differentiable at x equals to 0. So you see the questions of the derivative are basically boiling down to finding the derivative of the function at some point. So you'll have to be very, very clear with the idea of the it's boiling down to the finding the limit of a function. So you have to be very, very clear about how to find the limits of function. So then only you can actually understand the continuity and the differentiability of functions, right? So the concept of limits becomes very, very important. So as an exercise, discuss the differentiability of the given function of the following function at the point x equals to 0, where the function is fx equals 2 plus x greater than equal to 0, and 2 minus x. So in fact, what you can do is, now you know continuity also, differentiability and continuity also. All right. Okay. Now I will do some more questions. On differentiability and slope. Question is, does the parabola y equals to 2x square minus 13x plus 5 have a tangent whose slope is minus 1? If so, find an equation for the tangent and the point of for the line and the point of tangency. The question says, does this parabola have a tangent whose slope is minus 1? So you have to see if, firstly, does there exist a point where y dash x is minus 1? So we'll find y dash x by differentiating this. You can simply now do it by the power rule. So it will be 4x minus 13, right? So you have to see whether 4x minus 13 equals to minus 1 for some x. So yes, you can solve this equation. Minus 13 minus plus 12, x equals to 3. So at the point 3 comma y there will be 2x square minus 13x plus 5 at 3. The slope is equal to minus 1. So the point of tangency is 3 comma, when you put 3 here, it is 2 into 3 square, 9 minus 13 into 3, 39 plus 5 equals 3. So it is 18 plus 5, 23, 39 23, 6, 16. So the point of tangency is this, and equation of the tangent will be y minus 16, the slope is minus 1 into x minus 3. So y plus 16 equals minus x plus 3. So y plus x equals minus 13 is the equation of tangent, and the point of tangency is point of tangency is 3 comma minus 16, right? Okay. So a similar question I will do next. Does any tangent to the curve y equals to root x cross the x-axis at x equal to minus 1? If so, find an equation for the line and point of tangency. So you are given the curve y equals root x, that is y square equals to x, x equals to y square. So x is positive, so it will be somewhat like this, but y is also positive, so it is like this. So you given, you have to find, does any tangent to the curve crosses the x-axis, that क्या कोई ऐसा point exist करेगा such that it crosses this at minus 1. So I have drawn the picture like this, that it is crossing the point, but you'll have to do this mathematically to find out. Okay, so what do we do? So we have to find y dash x firstly, and then you have to find the, so let's suppose the point is a comma y of a, which is a comma root a, through which the tangent to the curve this y equals to root x passes the x-axis at x equals to minus 1. So let's see such an a, if it does it exist. So slope is using the curve y equals root x. So dy by dx is 1 by 2 root x, and at the point a comma root a is 1 by 2 root a, right? Also the slope of the line joining a comma root a, meaning I have supposed this point to be a comma root a. So this, the slope of this line and the slope of this curve have to be equal. So, and minus 1 comma 0 is 0 minus root a upon minus 1 minus a. So this has to be equals to 1 by 2 root a. So we get minus, cross multiplying, 2 into a equals minus 1 minus a. So we get minus a equals minus 1, implies a equals 1. So such an a is existing. So the point of tangency is a comma root a equals 1 comma 1. So 1 comma 1 is the point such that the tangent to the curve at that point will pass the x-axis through x equals to minus 1. And the equation of line or tangent is passing through this point is y, or you can take it, you find it using the point minus 1 comma 0 as well, y minus 1, and the slope was coming out to be 1 by 2 root a, y minus 1 by 2 into 1 into x minus 1. So this is y minus 1 equals 2 into x minus 1. So what do we say? y equals 2x minus 2. No, sorry. Yeah, minus 2 plus 1 minus 1. It is not 2, it is 1 by. So it is 1 by 2x minus 1 by 2 plus 1 by 2 will be 1, minus 1 by 2 plus 1 will be 1 by. So this is the equation of the tangent. Okay. The next question I will do in property of the derivative. So you know the intermediate property of the derivatives, right? This has also been discussed in the class. I'll just recall intermediate value property of derivatives. What does it say? If A and B are any 2 points in an interval on which f is differentiable, कि अगर कोई दो points है A और B where f is differentiable, then the derivative f dash takes on every value between f dash A and f dash B. So this is like the intermediate value property of the continuous functions. So this also sir has discussed in the class. So we'll do one small question based on this. This is basically used to tell you that application is not every function can be derivative of some function. कि हर function जरूरी नहीं है कि derivative हो of a given of some function, not a given function. So based on this, I have one question for you. The question is, does any function differentiable on minus infinity to infinity have y equals to floor function y equals to x floor as its derivative? Give reasons. मतलब क्या बोल रहा है वो क्वेश्चन में कि कोई फंक्शन ऐसा जो डिफरेंशिएबल हो और माइनस इन्फिनिटी टू इन्फिनिटी, क्या उसका डेरिवेटिव y इक्वल्स टू फ्लोर ऑफ x हो सकता है या नहीं? So the answer is no, clearly. Why? Using the intermediate value property. No, because if suppose g is a function differentiable on 1 0 comma 1 on say on minus infinity to infinity such that g dash x is f of x. I'm defining this to be f of x. Then implies g is differentiable on a small interval also on 0 comma 1, right? And g dash x is f dash x on 0 comma 1, right? By also g dash 0 is f of 0 equals floor of 0 is 0, and g dash 1 is f of 1, floor of 1 is 1. But f will not take any value, but there exist there but 1 by 2 belonging to 0 comma 1, but there exist no x such that f of x is f, or sorry, g f of x, yeah, is 1 by 2, and g dash x is equals to this. So g dash is not satisfying intermediate value property. So g dash equals to f implies f is implies no such g exist. You know that the floor function can only take the value if it is 0, then 0 1, like this, something like this, right? So they're not taking the intermediate value. So that's why it cannot be the derivative of any functions using the intermediate value property of the derivatives. Okay. One last question. Suppose that functions gt and ht are defined for all values of t, and that g0 equals h0 equals 0. Can limit t tending to 0 gt upon ht exist? If it does exist, must it be equal to 0? So those functions have which are defined for all values, and that at 0 they are 0. So the question is, does the limit of their quotient also exist, and has it to be equal to 0? So answer is it can or cannot exist. So limit gt upon ht can exist, but it might not be 0. So here exercises: find functions satisfying the above conditions such that limit gt upon ht does not exist. I'm giving the value function where it is existing, so let gt equals empty ht, or you just simply take to be t 2t, and t equals to t. Both are existing, both have value to be 0, and gt by ht is 2, and limit t tending to 0 is also 2, which is not equal to 0, right? So just try to find a functions where the value is not existing. Okay, so that's it from my side. I'll wait for 15-20 minutes. If anybody has any doubt, just let me know. Thank you. We'll meet next week with new questions.